Hello everyone, welcome back to Quiz TV. Now let's focus our attention on conservation of what linear momentum. And conservation of linear momentum is one big topic in physics that Jamb normally used to ask. You get. So we have done the first part of linear momentum, which we talk about the Newton's laws of motion, first law, second law, and third law of motion. Then look at what force, impulse, and momentum. So we did some key calculations you may likely see in your Jamb examination. So please, if you have not subscribed to this channel, please kindly subscribe. And if you have not watched that video, the link will be at the description below, because that is the first topic. This is what the second topic. So now, when we talk about conservation of linear momentum, conservation of linear momentum combine two laws of what motion, Newton's law of motion, the second law of motion, and the third law of what of motion. So what is the second law of motion? Newton's second law of motion. It states that the rate of change of momentum is directly proportional to what to the applied force, provided there is no external force acting on that what object. You get. So the third law of motion states that action and reaction are equal and what and opposite. So these are the two laws of motion, Newton's law of motion. You combine when it comes to conservation of linear what momentum. You get. Now remember, if for example, let me just give you an illustration so I can start asking this question. Yes. So please pay close attention here. Now remember, when we talk about momentum is what? Mass times what? Velocity, right? Mass times what? Velocity. Conservation of linear momentum states that the momentum before collision is equal to what? Momentum after what? Collision. So we are talking about two or more body. Now, if for example here we have this body, two body, we want to talk about two body together. Now this one, now let's say the mass one, here we have u1, here we have mass 2, and here we have what u2. Now at first, if this guy is moving due what not, he's moving towards here, right there, it has its own mass, it has its own what, initial velocity, right? Because I talk about momentum here, momentum with the what movement. So now, as it's moving, now if this guy is stationary, that is not moving, what will happen here? If this guy should move towards this guy here, they will stick together, right? Now, when they stick together, this is called momentum before collision. Momentum before collision. Now, if this guy is moving and he hits what a stationary what object that is at rest, that is not moving, you understand? What will happen here? Once someone hit this one here, they will stick together. Now, when they stick together, what will happen here? Now, they will have their different mass, m1, m2, right there. Now, but they will move what with the same velocity. So they have common what velocity, which is called the final what velocity. So at first, this is called before collision, before what collision, and here we have what afterwards collision. Right there, please, I want you to understand this here. So in the sense that at first, an object that is moving at a certain speed, it's an object that is stationary. Right there, they both have their different masses. Now, once this guy hits this guy here, they are going to stick together and move with common what velocity. So now it's collision. This is called collision before collision, because before collision they have their different what they have their different what velocity, right? Just that this one is stationary, while this one is moving. So when some move and in this one here, they now stick together, right? They now have what common what velocity. They now move with what in the same direction with what common what velocity. It shows that, remember, here now when we talk about momentum, remember here we have mass times what velocity, right? So here we have this momentum here of this object here, which is what m1 u1. Then we have this one here plus what m2 u2, right there. So you say that their momentum differs. So, but when they hit together, now when they hit each other here, what will happen here? They will now have common what velocity. So now you got to be what m1 plus what m2. Then we have what v. So now in when it comes to linear momentum calculation, your conservation of linear momentum calculation here, what you actually calculate is what is the common velocity they move together. So these are the stuff you want to look at. So when you're solving conservation of linear momentum. This is the formula you want to what, take note of here. Right there. Another thing here is that after after collision here, they can have what they can have what kinetic what energy. Right there. They can have what kinetic energy because they are moving now, right? They're now going to you can now calculate what their kinetic energy. Now, what is kinetic energy? Kinetic energy is K E equals to what? Half. Remember, kinetic equals to half mv square, right? Now, because they are stick together, the mass are not together, the two bodies are not together. So instead of saying half mv square, you're going to do what? Half m1 plus m2 d what square. Right there. So if they should ask you in the exam to calculate what collision, no, kinetic energy after collision here. Now, therefore, you have to calculate the collision. You have to calculate what the speed or what the velocity after what collision, the common what velocity here. So in saying that these are the two formulas you are going to use, mainly you are mainly going to use when it comes to what calculation of what linear what momentum. Do you understand? So this guy is to calculate what the final velocity that they use to move together after collision. Then this was called kinetic energy. Now the energy, that is the kinetic energy they possess when they are what moving. So how do you solve this problem here? So now let's take question 1 or question 2. We solve up like 3 to 4 questions in this video here. So let's take what the question 1. So let's take question 1 here. So look at question 1. Is that a body of mass 5.6 kg moving with a velocity of 14 meter per second. Again, due not. It's a stationary body of mass 8 kg. If they stick together after collision and move with velocity v, due not. Calculate the magnitude of what v. It's very easy. When you see this kind of question in the exam, it's very easy. Understand that m1 u1 plus what m2 u2 equals to what m1 plus what m2 here we have what v. Now this is what this is what common what velocity idea. So they say that a body is moving due not. The mass which called m1 is what is 5.6 kg, 5.6 what kg, and the initial velocity here, the velocity in which is moving is what, which u1 is what is 14 meter per second, right? 14 meters per second. So it's moving due not. Now this is that a body of mass 5.6 kg moving with a velocity of 14 meters per second due not. It's a stationary. So a body that is stationary, it was here. A body that was stationary was here. Because it was stationary, the initial velocity is going to be what 0 meter per second. So right there, 0 what meter per second, because it's not moving, it's stationary. Remember, whenever a body is a stationary, that is the velocity is what is 0 right there, so it's not moving. Well, now what is the mass? The mass is m2. The mass is what? The mass is what 8 kg. Can you see that? So the first body is mass of what 5.6 kg is moving due north with velocity, initial velocity of what 40 meter per what seconds, right? Now it's a stationary block. It's a stationary what? It's a stationary body that having a mass of what 8 kg. If they stick together, so now as they because they these guys one here, they now stick together. So if they stick together, that they stick together, idea. Now when they stick together, each of the body still have their different masses, right? So here we can see say m1 is still what is still 5.6 kg, right? And m2 is still what m2 is still 8 what kg idea. But they now move with common velocity. So they now move what common what velocity, which is what is the v. Do you understand? So this is what you want to calculate here. So now let's apply this formula here. How do we apply this formula here? M1 times V1. So my M1 is what? 5.6 times V1 is U1 is what? 14, right? Plus M2 is what? Is 8 times U2 is what? Is 0. Can you see that? Equals to, now going to be M1 plus M2. So my M1 is what? Is 5.6 plus M2 is what? Is 8. Then what? This velocity here, right? So 8 times 0 is going to be 0. 40.6 times 14. No, 5.6 times 14. Here we have 5.6 times what? 14. Here we have 78.4. 78.4, right? 78.4 equals to, because here is already 0, equals to what? 5.6 plus 8. Here we have what? 13.6, right? Volts or V. 13.6 what? V, which is what? Final what? Velocity here. So let's make V solve formula here. If you should make V solve formula here, we have V equals to what? 78.4 over what? 30.6. So what will be the answer here? 78.4 divided by what? 30.6. So you have 5.765 meter per watt seconds. So that is the common velocity here. The common velocity that they move that they used to move to is what? 5.765 meter per watt per second. So you can see that the question is not that too difficult. If you check it very well, the question is not that too difficult. So questions like this in physics, if you see in the exam, understand the questions, apply this formula here, and be able to get what the final velocity. Just please, if you have not subscribed to this channel, please kindly hit the subscribe button. And if this video is helpful, please leave a comment section that this video is helpful, because my aim here is to make sure that I guide you properly so that you can score very high in your Jamb examination. You get. So that is why I'm uploading videos, like 2 videos on a consistent basis, so that we're able to cover the most relevant topics in math, chemistry, and physics before your Jamb examination. And I know Jamb examination is very close, but you can still cover as much as you can if you actually will stay focused and determined and do exactly or take the structure I will give to you. Just so now let's move into what the next question. Let's move into an arrow of mass 0.5 kg is fired with a velocity of what? 120 meter per second into a wooden block of mass 0.75 kg. Into a wooden block of mass. That is, the block is not moving. The wooden block is not moving. That is, the initial velocity is going to be what? The initial velocity is going to be what? 0. Now say what? Calculate the final kinetic energy after the impact, given that the wooden block can freely move. So in the sense that there is an arrow here, let me choose. There's an arrow here. The arrow, the mass is what? The mass is what? 0.5 kg. Now it's moving with what? Initial velocity of what? It's moving with what? Initial velocity of what? 120 meter per second. Now there is a wooden block here. There is a wooden block that is not moving, and the wooden block, the mass, which is what? M2 is what? The mass is what? 0.75 kg. Now because it's a wooden block that is not moving, the initial velocity is what? Is 0 meter per second. Now if this guy should eat this one here, now this guy can freely what? Move. So in the sense that if the arrow pierces the wooden block, what will happen here? Now the mass of the arrow is still here, which was 0.5, right? The mass of the arrow is still what? 0.5. Let me wipe this out. Now the mass of the arrow, like this is the wooden block here, right? And the arrow hits it here because it's fired towards the wooden block here. So the arrow is still what? Is still M1, which is what? 0.5, right? The wooden block is still M2, which is what? 0.75 kg. Do you understand? It's very important here. Please just try to get what I'm doing here. Now, in the sense that the mass of the arrow still remain, the mass of the block still remain, right? Now they're going to have a common velocity, which is what? Is the V. Just now let's look at what they say you should calculate. They say calculate what? The final kinetic energy after the impact, given that the wooden block can freely what? Move. It means that if I want to calculate what my kinetic energy here, my kinetic energy after the impact or after the collision is going to be what? Half m1 plus what m2 v what square. That is it. Do you understand? So I know my m1, I know my m2, but what my v2, what my v final velocity? I don't know what my final velocity. Do you understand? So this way I'm not going to use what the sum of momentum before collision is equal to the sum of momentum afterwards collision. Do you understand? So for me to be able to calculate what the kinetic energy now, I must calculate what the final velocity that two of them move together. You get? So how do I do that here? I want to use what m1 u1 plus what m2 u2 equals what m1 plus m2 v. Do you get that? Now remember this guy is 0, so here I'm going to add what 0.5 times what times 120 plus m2 is what 0.75 times 0 equals to 0.5 plus what 0.75. Here we have v, right? So this one is already at, so 0.5 times 120, here we have 60, right, equals to what 0.5 plus what 0.75, right? So here we have 1.25 watts, 1.25 watt v, right? Make it v the solid formula here. Here we have v equals to what 60 over what 1.25. So what will be the answer here? 60 divided by what 1.25. Here we have what 48. Here we have what 48 meter per seconds. 48 what meter per what seconds. So here we now what 48 what meter what per what seconds. Do you understand? Now, but they don't. They say we will calculate what the final velocity. They say we will calculate what. They say we will calculate what the final kinetic energy. Final what kinetic energy. And now for you to calculate the final kinetic energy, you must sum what the two mass of what of the what object, the arrow and what and the wooden block, right? So let me write this place out. Let me use that to solve this one, the remaining part of the question. So yeah, remember, kinetic energy equals to what half m1 plus what m2 v what square, right? So what will that be the answer here? Going to be what half. My m1 is what? My m1 is 0.5 plus my m2 is what 0.75. Here we have v square. My v is only what 48, so going to be 48 what square. Can you see that? So here we now have what half times 0.5 plus what 0.75, right? It's going to be what? It's going to be 1.25 times now 48 square, 48 all square. Here we have what 230.4, right? So when multiply them, here we have 1.25 times 2304 divided by what 2. Here we have what 1440. Now remember, you're talking about energy, kinetic energy. So is what is in joules. Is what is joules. So the answer is what 1440 joules. See how easy it is. So let's see how we can what get on that question here. Let's see how we can solve on that question. Okay, now let's look at what this question 3. This question 3 is a little bit confusing and a little bit complex. But now, what about physics question is that for you to be able to solve any physics question, but therefore calm down and able to understand what they are talking about. Then try to figure out the formula you can use in solving this problem, because physics is all about what their formula. So let's tackle this question. You see that a tractor of mass 6.0 exponential 3 kg is used to tow a car of mass 1.8 exponential what 3 kg. The tractor moved with a speed of 4.6 meters per second just before towing the rope becomes stunt. Calculate the speed of the tractor immediately the rope becomes stunt. Now let me explain to you. Now let me just say there's a big tractor, there's a big tractor. This is a big tractor, right? Now it's used to tow a little car. Just used to tow a little car here. Now the mass of this one here, so here, of course, we're going to be m1. M1 is going to be what 6.0 exponential what exponential what 3 kg, right? Now, why this small one here is what is m2, because this is the car, the tow, right? 1.8 exponential what 3 what kg. Can you see that? Now, this is that the tractor move with a speed. So the speed, right? That my initial velocity or initial speed is what 4.6 exponential what 4.6 meter per second, just a meter per second. Now remember, a thing that is moving, this guy is what is not moving. So that is the initial velocity here, which was u2 is going to be what 0 meter per second. That is it. So these are all the what values you get, because a character move with the character of mass. Look at the mass of the character, which is m1. Is used to tow a car. That this car is what is initial, right? It's not moving. So the mass of the car is what 1.8 especially what 3 kg. Just now it's moving. Now the character moves with a speed. Look at the speed here, 4.6 meter per second. That is the initial speed of the car is 0. That is the car is not moving before. Just so now let's understand what they say should calculate. They say calculate the speed of the tractor. Immediately the rope it becomes taut. Now the speed of the tractor is going to be the speed of two of them, because it is tractor that is not moving that one now, right? So you are this way I want to use what conservation of linear momentum. Collision momentum before collision is equal to momentum afterwards collision. Do you understand? Now I'm going to be what m1 u1 plus what m2 u2 equals what m1 plus what m2 g. Now why is it like this here? Because now before collision, this is called before collision, right? Before collision, two of them have a different mass and what different what velocity, right? Now, but once this try to show it here, they now have common what velocity. So it is the common velocity you are calculating. So which go to be what? My m1 is what 6.0 exponential what 3 times my u1 is what 4.6. Can you see that? Plus my m2 is what is 1.8 exponential what 3 times what 0 equals to what you already solved 2 mass here. We're going to be what 6.0 exponential what 3 plus, right, plus 1.8 exponential what 3. Here we have what v. Can you see that? So these are going to give me 0, because 1.8 exponential 3 times 0 equals to give 0. So now let's calculate for here. Let's calculate this guy here. 6.0 exponential 3 times 4.6. What is the answer? You now have what 27600, right? Equals to here. You have 6.0 exponential 3 plus 1.8 exponential 3. You have what 7800, right? V. So now I'm calculating what the final what velocity now, which is what v equals to what 27600 over what 7800, right? So we have 27600 divided by what 7800. Here we have what 3.538 meter per second. 3.8 meter per what per second. So I'm going to just place it here. V equals to what 3.58 meter per second, right? So that is we have calculated A here. Remember, my m1, I'll put my m1. My m1 is what 6.0 exponential what 3 kg. My m2 is what? My m2 is what is 1.8 exponential what 3 what kg, right? Now u1 equals to what 4.6 meter per second, right? Then my u2 here, u2 equals to what 0 meter per second. So I can wipe this B, calculate what the loss of kinetic energy of the system just after the car have started moving. Now, if you want to talk about the loss of kinetic energy here, so loss of kinetic energy, loss of what kinetic energy equals what final kinetic energy, right, minus what initial what kinetic what energy is okay. So once I know what my final kinetic energy, I will subtract. Once I know my final kinetic energy, or initial kinetic energy, what I will do, I will subtract the formation. I'll get what loss of what kinetic what energy. Do you understand? So now remember kinetic energy. If you talk about kinetic energy equals to what? Kinetic energy equals to what? Half mv square. Are you there? Now let's calculate what the final kinetic energy. Remember in the final kinetic energy here. Now if I want to calculate what final kinetic energy, final kinetic what energy is going to be half m1 plus what m2 v what square. Do you understand? Now because in the final kinetic energy here, what happened here? The it contains what the mass of the tractor and the mass of the car, right? So we call final that we call final collision, like the moment after collision. Do you understand? So the mass of the tractor plus the mass of the car times the common what velocity raised from 2. So that would be what my final what kinetic what energy. Do you understand? So it means that my half times my m1 is what 6.0 exponential what 3 plus m2 is what 1.8 exponential what 3, right? Then my v, what is my v? My v that I've calculated final velocity, which is going to be what 3.58 all square. So I'm going to do the calculation. So when I do the calculation, 6.0 exponential 3 plus 1.8 exponential 3 times 3.58 all square divided by 2. So it's going to be, so my final kinetic energy, final kinetic energy is going to be what? 49983.96 joules. Okay. Now you can express it in what? In standard form, which is going to be 1, 2, 3, 4. So going to be 4.9983 exponential what? Exponential 4 joules, right? That is it. So they're going to be what? Final kinetic energy. So my final kinetic energy. So final kinetic what energy? Kinetic what energy equals what? Now let me say approximately what 5. Just now it's going to be 5 exponential what? 4 what? Joules. So my final kinetic energy here, final kinetic energy is going to be what? Now let's approximate it here because 4.9983 is also the same as what 5. So it will be 5.0 exponential what 4 joules, right? That was final kinetic energy. So let's talk about the initial kinetic energy. So how do you get the initial kinetic energy? Now the initial kinetic energy here. So the initial kinetic what energy equals what is going to be what kinetic energy of what of the moving tractor. Right there, because it was the tractor that was moving. So it's going to be what? So the initial kinetic energy equals to what? Kinetic energy of the moving tractor. So it's going to be Ke equals to what? Half mv square. Right there. So now my m now of the tractor. Remember, m of the tractor is what? Is the m1, right? So we're going to be what? Half times m1 u1 square. That is mu. So the mass of the tractor and the initial velocity of the tractor. Do you understand? So we're going to be Ke equals to what? Half times my m1 is what? 6.0 exponential 3 times u1 is what? My u1 is what? 4.6 or what? Square. Right? So let's use our calculator. So 6.0 exponential what? 3 times 4.6 squared divided by what? 2. So we have kinetic energy here equals to what? 63480 joules. Right there. So my initial kinetic energy now is now what? 63. So if I should convert it to what? To standard form, it's going to be 1, 2, 3, 4. It's going to be 6.348, right? Times 10 to what? 4 joules, right? So this is going to be what? Initial what? Kinetic energy. So my initial kinetic what? Energy what? 6.348 exponential what? 4 joules. That is it. Do you understand? So what happened here? Remember, the station will calculate loss of kinetic energy. I thought that loss of kinetic energy because of final kinetic energy minus initial what? Kinetic what? Energy. Do you understand? So this was my final, this was my initial. So I'll just bring out what the values here and subtract them together. So my final is what? 5.0 exponential what? 4 minus 6.348 exponential what? 4. Right? Subtract them from each other. Here we have 5.0 exponential 4 minus 6.348 exponential what? 4. So we have minus 13480 joules. Now this minus you are seeing here means what? Loss of what? Kinetic what? Energy. Do you understand? So this minus you are seeing here means what? Loss of what? Kinetic energy. So my loss of what? Kinetic energy is what? 13480 joules. That is it. Do you understand? So we are going to end this class here, although there are still a lot of questions to solve, but we are going to end our class here. Okay. Now, but see, we have not done C. Impulse in the what? In the rope when it jacks the car into motion. So when you talk about impulse, impulse equals to change of what? Momentum, which would be final momentum minus what? Initial what? Momentum. Do you understand? So C. C. Now, how do you calculate C? Now, impulse. If you look at impulse equals to what? Change of what? Momentum. Change of what? Of momentum. I get. When it comes to change of momentum, change of what? Momentum equals to what? Final momentum minus what? Initial what? Momentum. Is okay. So how do you get my final momentum here? So my final momentum, so you can say final momentum equals to what? M1 plus what? M2. Here we have V, right? M1 plus M2. Here we have what? V. Initial momentum equals to what? M1 U1 plus what? M2 U2. Right there. That is it. So it's going to be M1 plus M2 V minus what? M1 U1 plus what? M2 U2. Just understand? So you want just to substitute your values here. My M1, what is my M1? My M1 is what? 6.0 exponential what? 3 plus M2 is what? 1.8 exponential what? 3. Here we are what? My V, what is my V? My final velocity. Where is my final velocity? I'm looking for my final velocity. So I cannot see my final velocity, but I believe you should be able to solve this one here. So sorry about that. I can't really find my final velocity, so I cannot actually go back. So, but this is the formula here. For such get supply from this that one here, you get your answer. You get. I believe this video is helpful. So we are going to end this class here. Thanks for watching. I hope you have subscribed to the channel here. More of this video will be coming up. Thanks for watching. See you in the next video.